For my presentation on my favorite perception topic, I chose something within color, chapter 9, color perception. I chose color deficiency and color blindness because I was so fascinated about the fact that there's a difference between being colorblind and having a color deficiency, because growing up, people who suffer from a color deficiency even refer themselves as to being colorblind, when really that's not the correct term. So it's interesting to find out that there's a difference and how different between the two things are. Because going into color blindness, another term you can refer to is monochromatism, which means someone who suffers from this has no functioning cones and they only have rods. So they have no colors that they can see. They can only see gray, white, and black, and this causes them to be very sensitive to bright light, which can cause issues with driving and being outside in general. They usually have poor vision, and this is a picture that shows what it would look like for a person who suffers from monochromatism on the daily basis, that they can't distinguish any colors at all. And then color deficiency is also known as dichromatism. There are 3 types: presbyopia, dermatopia, and tritopia. All 3 of these are missing one of the 3 cones, and they can only experience some colors and not all. Going into the first one, presbyopia, this is when you're not able to see the colors green or red because you're missing the long red wavelength, and you're only able to see short wavelengths of blue. You also are able to see yellow past above the neutral point on the color spectrum. So for someone who suffers from this, there's a color wheel that shows that they see lots of shades of blue and yellow and gray. They also see shades of brown as well. This only affects 1% of males and 0.02% of females. It's very rare for a female to have any of these conditions, because it is genetically carried through the men genes and not through women genes. Next we have dermatopia, which you're missing the green wavelength. So you also aren't able to see green as red just as well as presbyopia, and you also are able to see yellow. This affects the same 1% of males, but only 0.01% of females. It's lower for females that suffer from this. You're still not able to see the same colors and are able to see the same colors as well. This last one is very uncommon. Tritopia, you're missing the blue wavelength, and so you're not able to see the colors green or yellow, but you are able to see red. So for someone who suffers from this, they see lots of shades of blue and red and pink and light colors, but no greens or yellows. This is rare because 0.001% of females suffer from this and 0.002% of males suffer from this. I personally have met a lot of people who have the color deficiencies of presbyopia and dermatopia, but I have not met anyone who suffers from tritopia. That's how rare it is. Also suffering from color blindness, 10 out of 1 million people suffer from true color blindness. So if you suffer from color deficiency, you're able to get glasses and specialized contacts, which are specialized to what type of color deficiency you are affected by, and it adds in the pigments, so you are able to see. If you're suffering from presbyopia, you are able to see red and green. If you're suffering from tritopia, you're able to see yellow and green as well. They also have visual aids, which come in handy when you're on any sort of smart device. If you want to play a game, there's many settings now that they have included in games recently, so where you can change how it has different colors. You change it to shapes or numbers. That way everyone can be involved. To know if you're colorblind, you can know from the doctor from a young age. It is very obvious to know if you're colorblind, especially for children when they go to school and they're saying, oh, this is red, and they see colors such as gray or brown. And there's also a free colorblind test you can take, which is widely used. And it's just a sequence of numbers that are little dots of different colors, and it's different numbers. So inside the circles, there's going to be like red and yellow or green, and then the number is going to be like with the opposite. So if you're red, green, colorblind, they target that, so you would be able to know because you would not be able to see the number. In this example here for the number 7, is I was red. If I was suffering from prenopia, I would see all gray here and not red and then green on the inside. It's a simple test, and there's no way you'd be able to fail it and get a false reading. So this is my project.